Astronaut suits are color-coded survival systems. The orange suit and the white suit exist for different mission phases. They solve different problems. They tell the rescue crew where to look. They tell the thermal engineer how heat moves. They tell mission control what environment the astronaut expects to face. The orange suit belongs to launch, re-entry, abort, and rescue. The white suit belongs to spacewalks. That sounds simple. The operational logic behind it is serious. A spacecraft crew moves through two different danger zones. First comes the atmosphere, where a launch vehicle can fail, a capsule can splash down off course, and a rescue aircraft may need to spot humans in open water. Then comes the vacuum of space, where sunlight can cook one side of a body while shadow freezes the other. Orange solves visibility. White solves heat. That is the briefing. Start with orange. The bright orange suit used by NASA astronauts is called the Advanced Crew Escape Suit, or ACES. It became famous during the Space Shuttle era. Crews wore it during launch and re-entry, the two phases where the spacecraft carried the most immediate abort risk. The suit was never meant for walking around the moon or repairing a satellite. It was designed for survival after a launch or landing emergency. If a shuttle had to abort, eject, ditch, or land in an unexpected location, the crew needed pressure protection, oxygen, flotation, communications, and visibility. The orange color served the last role with blunt practicality. Rescue crews can see orange. They can see it against blue ocean, gray clouds, white foam, brown terrain, and dark wreckage. Orange grabs the eye because it clashes with most natural backgrounds. Nature rarely paints the open sea in traffic cone orange. Even the ocean has better taste. This is why high-visibility orange appears in hunting gear, life jackets, survival equipment, road work, and aviation rescue gear. It marks a human body as something that should be found fast. The shuttle suit reflected that logic. It carried survival gear. It included an integrated parachute harness. It connected to the orbiter's systems during flight. It helped protect astronauts during cabin pressure loss. After splashdown or emergency egress, it helped keep them alive until recovery forces arrived. Orange was a rescue color. The same logic appears today in modern crew launch suits. SpaceX's Crew Dragon suit is white, which gives it a different visual identity, but it still functions as an intravehicular activity suit. Boeing's Starliner suit is blue. Russia's Sokol suit is white with blue fittings. China's launch suits use white as well. The color varies by program. The function stays fixed. Launch and entry suits protect the crew inside the spacecraft. They are pressure garments for emergencies. They support survival during the violent parts of flight. They connect to the capsule or vehicle. They carry communications and cooling support. They provide a last line of defense if the cabin fails. The orange shuttle suit became iconic because it matched the rescue mission perfectly. If a crew floated in the ocean after bailout or emergency landing, orange helped the helicopter crew find them. That is all. No mystery cult. No secret code. No aerospace fashion committee sitting around asking, what says orbital danger but also autumn pumpkin? It was a survival choice. Now shift to white. The white spacesuit is the suit most people picture when they hear the word astronaut. The bulky suit, the helmet with the gold visor, the gloves, the backpack, the suit used during a spacewalk. NASA calls that kind of operation EVA, or extravehicular activity. An astronaut leaves the spacecraft and works in open vacuum. That suit is a small spacecraft shaped like a human. It provides pressure. It provides oxygen. It removes carbon dioxide. It controls temperature. It manages humidity. It carries communications. It gives the astronaut drinking water. It protects against micrometeoroids and orbital debris. It allows movement, tool work, and crew rescue. The suit is white because space is a thermal knife fight. In orbit, there is no thick atmosphere to spread heat around the way air does on Earth. Sunlight hits directly. Shadow cools fast. A surface in full sun can heat severely. A surface in darkness can drop toward deep cold. The astronaut cannot rely on wind, convection, or a normal outdoor environment. The suit has to manage heat by reflection, insulation, conduction through internal layers, cooling loops, and radiation. White reflects sunlight. A darker suit would absorb more solar energy. That creates a thermal problem. In low Earth orbit, an astronaut can pass from sunlight into shadow roughly every 45 minutes during a 90-minute orbit. The suit must keep the astronaut within a safe temperature range through repeated heating and cooling cycles. White helps reduce heat absorption during sunlight exposure. That is the first reason. The second reason is visibility against space. A white suit stands out against the black background of orbit. It also stands out against much of the hardware around the International Space Station. Astronauts conducting EVA must be visible to crewmates, cameras, and mission controllers. The suit needs to be trackable. White works well for that. During the Apollo moon landings, white also helped reflect harsh solar radiation on the lunar surface. The moon has no meaningful atmosphere. The surface can become extremely hot under sunlight and extremely cold in shadow. The suit had to protect astronauts as they walked, drove, sampled, drilled, and worked under direct solar exposure. White reduced absorbed heat. The Apollo suits also used colored markings to distinguish crew members. On later lunar missions, commanders wore red stripes on their suits and helmets. That helped viewers, mission control, and crewmates tell one astronaut from another. Even in space, someone has to know which man dropped the tool. The white EVA suit is built in layers. The outer layer reflects sunlight and resists abrasion. Other layers provide insulation, pressure retention, micrometeoroid protection, and structural support. The backpack, called the primary life support system, handles oxygen, cooling, carbon dioxide removal, and power. The color is part of the system, but the suit's function comes from the full architecture. This distinction matters. Orange suits are worn inside spacecraft during launch and return. White EVA suits are worn outside spacecraft during spacewalks. One prepares the crew for an emergency in atmosphere or inside a capsule. The other allows the crew to survive in vacuum. Orange says, "Find me." White says, "Keep me alive in sunlight and shadow." There are exceptions because aerospace programs make choices based on vehicle design, mission profile, legacy hardware, branding, and engineering constraints. Mercury astronauts wore silver suits. Gemini suits were white. Apollo suits were white for lunar operations. Shuttle astronauts wore different suits across the program. Early crews used ejection escape suits. Later crews wore blue flight suits during some periods. And after the Challenger disaster, NASA returned to pressure suits for launch and entry. The bright orange Aces suit became the best-known version. The Challenger disaster changed the conversation because it exposed the need for better crew escape and survival capability. After that, the launch and entry pressure suit became a visible reminder that ascent and re-entry are dangerous phases. Aerospace optimism looks better when it remembers physics carries a vote. Spacesuit color also signals mission architecture. A crew riding to orbit needs a suit that works with the spacecraft. It must connect to life support and communications. It must allow seated operations. It must survive pressure loss. It must be light enough and flexible enough for launch procedures. A crew working outside needs mobility and independent survival. The suit must allow arm movement, hand control, tool handling, tethering, translation along handrails, and hours of work while sealed from vacuum. Those jobs conflict. The launch suit can be slimmer because the spacecraft supplies much of the support. The EVA suit must carry its own life support. That makes it larger, stiffer, and more complex. A launch suit is a pressure garment. An EVA suit is a personal vehicle. The color follows the job. Orange belongs to search and rescue. It makes the astronaut visible in the atmosphere, ocean, desert, or landing zone. White belongs to thermal control and EVA visibility. It reflects sunlight and helps astronauts stand out against the blackness of space. The human eye sees a uniform. The engineer sees a mission phase. That is the real answer. Astronauts wear orange and white because spaceflight moves through different hazards. During launch and re-entry, the astronaut's enemy is vehicle failure, cabin pressure loss, water landing, smoke, fire, and delayed rescue. Bright orange helps recovery teams locate the crew and treat them as survivors. During spacewalks, the enemy is vacuum, solar heating, cold shadow, radiation exposure, micrometeoroids, and the total absence of natural life support. White reflects sunlight and helps the suit maintain thermal balance. One color is for being found. One color is for staying alive. Spaceflight has very little room for decoration. Even its colors carry orders. Orange tells the rescue pilot where the human is. White tells the sun to take less of a bite. That is why astronauts wear them.